Welcome to Zukkun Knows. Everyone's talking about quantum computers. They're supposed to be millions of times faster than regular ones. They could break encryption, transform science, even rewrite the rules of reality. But what the heck is a quantum computer? And how is it different from the computer you're using right now? Let's break it down, step by step. 1. What's a normal computer? A normal computer uses bits. Each bit is either a 0 or 1. Millions of these bits work together to represent numbers, letters, pictures, everything. They are stored using tiny switches called transistors that are either on or off. 2. How is quantum different? Quantum computers use qubits instead of bits. And here's the weird part. A qubit can be 0 and 1 at the same time. This is called superposition. Imagine flipping a coin and it stays spinning in midair. That's a qubit. 3. Why is that powerful? Because with every added qubit, the computer gets exponentially more powerful. 3 bits can hold one value at a time out of 8 possible combinations, 2 to the power of 3. But 3 quantum bits, qubits, can hold all 8 combinations at the same time. Here's the wild part. Even if you had millions of qubits, the time it takes to process them doesn't grow the same way it does in a normal computer. That's because quantum computers use superposition to try all combinations at the same time. So even mind-blowingly large calculations, like breaking a huge encryption key, could, in theory, happen in seconds instead of years. 4. Entanglement. The quantum-linked qubits can also be entangled. That means changing one can instantly affect the other, even if they're far apart. It's a weird, spooky connection that Einstein called spooky action at a distance. 5. What can it do? Quantum computers aren't good at everything, but they can solve very specific problems. Way faster. Cracking complex encryption, modeling molecules for new drugs, optimizing huge systems like airline schedules or factory logistics. 6. Can it break encryption? Yes, and that's the scary part. Most of today's online security, like credit cards, bank logins, and Bitcoin, uses a system called RSA encryption. A normal computer would take trillions of years to break it. A quantum computer, in theory, minutes. 7. So why don't we have one yet? Quantum computers are really hard to build. Qubits are fragile. They need to be super cold, near absolute zero, and protected from noise. One wrong move and the whole calculation collapses. 8. Who's building them? Big tech companies and governments are racing to build them. Google, IBM, Microsoft, China's national lab, startups like Rigetti and IonQ. But as of 2025, we're still in the early stages. The most advanced machines have only a few hundred stable qubits. 9. Will they replace my laptop? Nope. Not anytime soon. Quantum computers are like rocket engines. They're great for very specific missions, but terrible for day-to-day stuff. Your laptop is safe. 10. Final thought. Quantum computing isn't magic, but it's close. It's a new kind of logic based on physics most of us don't encounter. And if we figure it out, it could change everything from medicine to math. But here's the catch. Quantum computers won't be in everyone's hands. They'll be expensive, rare, and controlled by the few. So the real challenge isn't just building them, it's making sure the power they bring doesn't widen the gap between the powerful and the rest of us. Thanks for watching Zukkun Knows. Stick around, and don't forget to subscribe for more mind-blowing tech explained simply.